All right, what is an engineer and what do they do?
They fix cars.
They fix stuff.
They
They
fix
build
things.
things.
They fix and build things,
STEM stuff.
right?
So you're saying they fix stuff, fix buildings? Is that what you said? They, fi- they have
They
blueprints?
fix cars.
Fix cars? Okay. Here's some pictures to help you think about it. They do what? Make machines? What else? Any other thoughts? Look at the pictures. What are the things can you toss out about engineering that you know of? Solve problems. Anything else?
They create stuff.
Okay, they create things.
They create efficient things.
Create efficient things. Good word, efficient, to toss out there. All right, here's a video to maybe answer some more questions maybe you didn't ask or bring a little bit more to the table.
Engineering can be described as
So, what needs to be engineered for a stadium? You know, stadiums are pretty massive. What type of things might need to be engineered for that? What might something engineer work with? The size of it? Okay. How big it needs to be or can be? The structure of it. It's gonna be a lot of weight, even without all the fans on it. They're massive, they're heavy. What else?
The measurements, like to get all the measuring for how far the seats are gonna be for how
Okay.
high because like you know how there's panels under the seats where the players can walk through.
Mm-hmm.
How the poles are gonna be setted so they just so everything doesn't come falling down.
Okay. All that structure, how many restrooms there's gonna be, the seating location, like you're saying, how many seats? Anything else that you can think of? Yes?
Budget.
The what?
Budget.
The budget. Yeah, that's a pretty big one. How expensive is this gonna cost? What could be afforded?
It can be cheaper.
Okay, that's true. So, here's some that you mentioned, how big it can be. That's good with the budget. Type of structure needed. They have a lot of cement and steel and stuff like that. Which materials can handle the weight? How much parking? We didn't talk about parking. How much parking is needed to match the size of the stadium? These stadiums tend to have a significant amount of land that's paved over just for parking. You know, and so you might want to balance the cost. How many parking garages can we build? If you're in a bigger city and there's not a lot of land to grow around it, you might have to build a lot of parking garages. What about extreme weather?
Oh, I think it closed the.
Some of them do that. This one doesn't, but like stuff like the Superdome, the Dallas Cowboys Stadium, I think the Viking Stadium has one. They'll have a lot of where they can just cut out the weather completely and have a game separate from the outside. But to do that, you have to build something that can handle extreme weather in your area, such as like the Superdome in New Orleans where the Saints play. Their structure is built to handle a Category 5 hurricane. When Katrina was hitting New Orleans, the mayor had told people that were still in the town to seek refuge in the Superdome because it was built to handle that type of weather. And it did. It was completely enclosed. There was like some minor leaking issues that the engineers were kind of caught off guard by, but the structure didn't fall, didn't waver. There was some flooding, and that was due to all the levees that were breaking down, but the people who were there were completely safe. So different different things like that are important because it's such a massive structure. You could use it to hide people in case of certain stuff like that. What about with farming? Is there engineering and farming that you can think of? What's some stuff, without looking ahead on the slide, what's some stuff that you know engineering might be involved in? The tractors? Yeah. Good. Chemical engineering for fertilizer. What else? Anything else that comes to mind besides the tractors? Those are pretty big machines. Pretty efficient too, sometimes.
The watering.
Oh yeah, all the irrigation systems are very different. You know, if we think about early mankind setting up like irrigation systems to farm out land away from rivers to bring the water to other fertile lands. You're bringing the water to you, but now we have a totally different way of doing that type of stuff. Have you guys ever seen these before? This is satellite imagery of farmers, modern farming land. Why are they all circles like that? Or half circles too. Some of them aren't even full circles. The aliens, they're crop circles. No, I mean, usually when land is sold, it's sold with corners. It's what you said, the irrigation systems. They tend to run on like a center post and they rotate around the land. Yeah, because it's more efficient. Because we, our understanding of ecology, biology is better. We understand how the plants, you know, their cycles with need for sun and how to be more efficient with water, so we can run those things. They usually run in circles like that. And plus, we understand better with fertilizing and genetic engineering. I know when you hear the term genetic engineering, people kind of have this misconception about it. But mankind has been using genetic engineering in farming for thousands of years. It's not some new concept. You can look back through archaeological sites and find corn in the oldest of Inca sites, and their corn is real small. It's a really tough kernel. And then you can find in the newer Inca archaeological sites that their corn is larger, it looks softer, because it's easier to eat. The way that you genetically engineer at its base is you plant plants, and then the plant that gave you the best fruit, you take those seeds, and then you plant those. And you just keep doing that process till you get a domesticated version of that plant that you have genetically engineered to be tastier, easier to eat, produces more of the fruit. Like if you look at wild avocados versus farm-raised avocados, the wild ones is like all seed and then just a small little bit of greenness around it. Farm-raised one, the seed's pretty massive still, but you have a significantly more amount of green flesh that you want to eat around it. Bananas too. Almost anything, even just like simple grain, like wheat and stuff like that. You can tell a difference between wild wheat and farm-raised wheat because we've genetically engineered over thousands of years to just be better for us in the long run. It produces more for us. In modern farming, of course, when you bring in all the machinery, understanding of the actual plant science and better fertilizers, better watering systems, that we can actually produce like more food, a significant more amount of food and richer food with a significant less amount of land and significant less amount of water. So the modern science can now do more with less. And if we can just continue to spread that kind of stuff, it just gets better when we start using our better understanding of science and the technology we have around us. All right, here's a definition of engineering I'd like for you to get down on paper. So write this definition down.
On what page of the?
I would flip 2 pages open. Use any paper you have now and get your notebook as soon as you can.
Wait, what page?
I would leave the first 2 pages blank for your table of contents.
So like on page 4 or 5?
Something like that, yeah. Because each page has a front and a back, and usually when you look at a book, they put a number on both sides. Yeah. Your side, you choose, but leave the first few pages blank for the table of contents. Open it up at your desk on Canvas. So, engineering, this is making practical application of the knowledge of science. Usually in physics or chemistry, usually in engineering, biology is less. And it's more physics and chemistry that comes up, but biology isn't completely removed. You can definitely have, in the medical community, there's a lot of biology there, and you could have a lot of engineering involved in helping the human body, machines to work with the human body, drugs for the human body. So there's biologies involved, but most of it, the lion's share of it, is in physics and chemistry. With the purpose of bettering mankind. That's the making the application of the knowledge of science with the purpose of bettering mankind. With the purpose of making improvements, with the purpose of efficiency. You mentioned more efficient machines earlier. This can include a lot of things like designing of machines, bridges, buildings, ships, factories, inventions, innovations. It can include all of those things and much more. It's just a very, very tiny list that would make sense. If you look up the definition of engineering, you can of course find a wide variety of things that are mentioned, but a lot of key words in there is like designing and application of science, bettering mankind, efficiency. These are all, I tried to already condense down what I knew of it, kind of give you a very condensed definition, so you don't have to write as much. All right, can an engineer fix your car? Yeah? An engineer can fix your car? Could an engineer fix your phone? Probably. Could an engineer fix your computer? Sad. It's not working quite right. Keeps, every time I press the G button, the H button goes off. Could an engineer fix my computer has viruses? What about my Xbox, Red Ring of Death? Could an engineer fix that? Maybe? Lack of confidence. Let's discuss some more. So, keeping those in mind that I just said, let me bring a few things forward that there might be some differences, they might be similar. I want you to discuss among yourselves. So you might have to move to discuss with someone or talk louder. So here's the question. What is the difference between a mechanical engineer and a mechanic? Similar or different?
Different.
They're different? Okay, so what are some of the ways that you believe that a mechanical engineer and a mechanic are different?
A mechanical engineer is mainly focused on creating new things for your vehicle, but a mechanic is mainly focused on repairing your vehicle.
Okay. There's still some issue there that's not quite right, but it's a good improvement, because before I definitely heard a lot more, yeah, an engineer could fix your car, but now you're starting to see that there's a difference when you're starting to think about it. A mechanic is there to repair cars. That's what mechanics do. Though you can have helicopter mechanics and airplane mechanics and so forth, but when we think of mechanic, we usually think of someone we go to fix the car, right? A mechanical engineer could design a car. They could also design a jet. They could design a bomb. They could design a mechanical pencil. They could design a clock. Like, it doesn't have to be just cars.
I cheated.
You cheated and looked up stuff on the internet?
Yeah.
Yeah? All right. No, and a mechanical engineer needs to have at least about 4 years in college. They get a bachelor's degree. A mechanic, you can go to get a degree to be a mechanic of different trades, diesel mechanic, mechanics for specific brands, and you could do that. You could become a technician like that for specific certain things. But a lot of mechanics are also just like, it's like a family trade. Like their grandfather was a mechanic, their dad was a mechanic, they own a mechanic shop. That type of thing also happens, and college isn't necessarily needed in some sense for that. Though because cars are becoming more technical, it might need to have, but it's almost never a mechanical, it's almost never like a 4-year degree or anything. It's like an associate's degree, which is like a 1.5 years, 2 years. That's one difference at the beginning, at least. You wouldn't be able to be a mechanical engineer without a degree path. To get that formal engineering training that you would need, all the complicated math that you might run into in science. All right, so pretty good differences there. What is the difference between an electrical engineer and an electrician? Are these the same? Maybe they mean the same thing, but they just have different terms. You know, like a pumpkin is a pumpkin, and a squash is, you could also call a pumpkin a squash because it's in the squash family. You know, like it's a gourd of sorts. It's like, are they the same thing? Like a square is technically also a rectangle, right? It's got 4 sides, 90 degrees. You know, or is there a difference? So same thing. Discuss with each other. Well, what have you discussed with this one?
Yeah.
What? Yeah, they're saying they're different.
They're different
How are they different?
because electronic. Wait, what are they called?
An electrician?
That one. They like they deal with
Nice
like
stutter.
TVs and stuff, and then the engineer one they like do the
Oh, yeah, I'm gonna need you to come back
currents
and
and
sit down.
currents and stuff.
Way more than that, but
Wait, that-
not fully wrong.
I bet you like that makes sense.
That made no sense to me.
Huh?
That made no sense to me.
That
what
makes
she
sense?
said.
She stumbled over it. What makes sense to you? Nothing makes sense to you? Perfect. What are there?
This is like the same thing as a mechanic. One of them mainly focuses on getting you better internet and like cable and stuff, but the other is like makes things for you that can get you faster.
Oh.
Okay, I think your first
It's
sentence
the same
worked.
thing as the other
It's
one.
the same thing as the last question, but I don't know about getting you better internet or anything.
Oh. Okay.
Um,
I didn't know.
So, so electrical engineers designing anything that deals with electricity, right? That could be basic things to like battery design. That could be to production of power, like power plants. And there's a whole variety of those with windmills, nuclear power, gas power, wind turbines. I think I said that. Water turbines. Anyways, solar panels. A lot of ways to get electrical, and a lot of ways and to send electrical to electricities to buildings and houses and neighborhoods and stuff like that in cities. There's a lot of design in the engineering side that would go into the transmission of electricity, or into incredibly small, sophisticated microchips for computers. None of that is so much electrician. But an electrician might be wiring an entire home or a building. So different from the mechanic and mechanical engineer, electricians don't just do repair, they also do installation. So they might install all the wiring, and that could include internet wiring, that could especially would include power lines, or not, they wouldn't be called power lines in the house, but all the electrical wiring, all of that stuff would be installed by an electrician. And if there were issues with any sort of electrical thing within the building itself, then an electrician would be called to repair it. So it's a little bit of difference between the last example. This one might be much harder. Is there a difference between an engineer and an architect? They're both designers.
Architect.
So are they the same thing with different applications? Are they not the same thing? Discuss again. Discuss again in your small groups.
Or which one?
The one that's up there, architect and engineer.
Yeah, those things are definitely not the same.
Okay, discuss it with each other.
Yeah. Engineer is like engines and architect is buildings. Right, Seacrest?
Architects with blueprints and stuff.
Yeah, like building stuff. And an engineer is like, yeah, I'm gonna need that oil change.
I think they're different,
See?
but if it's
Okay.
a
Okay.
civil
Okay.
engineer, then
You're right. Civil engineering is a good thing.
Ooh, I wrote it down.
There is a branch of engineering that does work with buildings, and you brought it up. Yeah, civil engineering. Civil engineering has to do with all types of civil structure that society uses. So an architect for sure is buildings, which could be entire cities, but engineers don't tend to work with buildings as much. But there are a lot of engineers that do work with architects. So there are engineers, like you said, civil engineers, that tend to work with the architects and doing stuff like that. So let's get a definition down of an architect to start distinguishing the difference. An architect is a profession of designing buildings, communities, and other constructions, usually with some regard to the aesthetic effects. So what is the word aesthetic?
The visual piece,
Like static?
Aesthetics, not static,
Oh.
aesthetics.
the visuals.
The visual, it's how appeasing it is visually, yes. So how it looks, I always think of the term beauty is in the eye of the beholder. Like how it looks, is it beautiful to look at? That kind of thing. They're not necessarily working on, will the building stand? They're not thinking about the structure necessarily. Architects often include design or selection of furnishings, decorations, including even the supervision of construction work, restoration, and remodeling of existing buildings. When this school was designed, the architect picked the cabinetry in the rooms, the color, wall colors. They picked where windows would go, the size of the rooms, the size of the halls, location of bathrooms, and what the bathrooms. They picked how all of that looked, sizes and dimensions of that. But the architect didn't engineer the structure of the building. So they designed the look. Then they work with a structure engineer or structure engineering firm and say, okay, this is what we want. Can you tell us, work out all the math for the structure that's needed to make this 2-story building fit? So the structure engineer didn't say, okay, you need 3 buildings for the classrooms. That was an architect decision working with the school district. And other engineers that go into that are civil engineers, would be designing how high the finished floor would be for flooding, how the yard is graded for getting the water away from the building, how big the ditches need to be, the water lines need to be, where those are going to be, the size of the AC unit was probably determined by a MEP engineer that stands for mechanical, electrical, and plumbing. So they design everything that has to do with the AC work, the plumbing work, the electrical work. They do the design side. And then the electrician installs those things, the plumbers installs those things, technicians install the AC units. So there's a whole bunch of different types of engineers that are going to work alongside the architect. The architect isn't math and science based. They're not answering the questions of how the building will stand, how much do we need to prepare for flooding, where the fire hydrant line is going to go, how big the AC unit needs to be to keep everyone cool. None of that. That's not the stuff that they do. They're in a much more aesthetic look. Maybe the function of the building, the size of the things, the size of the hallways, the classrooms. Sometimes even the furniture, like the chairs are consistent through about everywhere except for I think the science rooms maybe. That could have been an architect decision. I know the architect chose the color choices across the campus. I know that was an architect decision. I don't know, you haven't been here very long, but you notice that I have a green wall?
That's green. I thought that was gray.
It's a grayed out green.
That's like dark green, like Olive Garden type.
It's like, olivey green, yeah. And then notice I have red cabinetry.
I thought that was like brown. Like, it looks red though.
It's red. It's red. All the classrooms have the red cabinetry. All the classrooms have, I think, a green accent wall. Did you notice that in the hallways, there's like, the end of the hallways, maybe you'll notice it once you leave my classroom in a little bit, but the hallways all have, they end with an orange wall. All the doors are all orange. And if you notice, in the middle of the hall, there's like a red square. And I think if you look on the ground, there's like greenish tinted colors for tiles and white colors for tiles and brownish red colors for tiles. Those were architect decisions. In the cafeteria and in the library, that's where all the raven colors are. There's a ton of blues over there.
Navy-ish type.
Yeah, navyish colors.
I haven't
Why
been-
aren't there a lot of navy colors in here?
Because it's a question.
It's not pleasing
Navy's not pleasing. I don't know. I like blue.
to the architecture.
Can you tell me where else you know
The locker
that
room?
we have the colors of green
Oh.
and red and orange and white?
The restrooms.
Oh,
Which is near,
wait,
the high
the high
schoolers.
schools.
The high schools.
Yeah.
The architect wanted to mix the Cardinals and the Hawks colors throughout the educational portion of the school because this is the one year that those schools are united. That was like an architect decision. It has nothing to do with math and science. It's all about aesthetics. In fact, probably most math and science people wouldn't even notice it. I wouldn't have noticed it unless,
You pointed us.
it was pointed out to me,
Right
you know.
now, so I just noticed.
But I know I was told that was an architect decision. I've been here since the school's open, and I remember them saying that, and then, noticing it, like, oh yeah.
2000 something. Right?
It opened in like 2013, I think.
Um,
So I said this, but I didn't. I forgot to put it up on the thing. So an architect is more of an overall designer and supervisor. Architects are like the managers of the project in this sense. They're like the supervisor of the larger building project. They're much less math and science. So they'll turn to the engineer to solve those types of issues. They'll turn to the, like I said, the structure engineer, the civil engineer, the MEP engineer, work with people like that in order to make sure that the building actually works correctly and get those math and science things worked out on paper and computer simulations to make sure things work right. Again, the definition for engineering, I've underlined a few key parts here. It's about the practical application of the science. Looking to better mankind, looking to make improvements, looking to make things more efficient. And a key word is designing. Designing is the key word in what we're talking about here. How are they going to be designed? Engineers don't build necessarily, they design. That's much more of what they do. Building is like what the technicians who make the cars in the factory do. Building is what like the construction workers do. It's the wrong verb. Design is much more of the verb that goes with engineers. Though engineers, depending on the profession they're in, they most definitely would get their hands into things that they're going to build a prototype, a working model. But when it comes to making a bunch of them after it's been designed, it's not really the engineer anymore. It's now moved to factory workers, construction workers, and so forth. All right, so I think we'll stop there and we'll pick up with scientists versus engineers and go with that. Yeah.